Hey class, let's go over our case study for this week that's due on Sunday. If you need extra time, the late policy is just to send me an email saying that you need a little extra time. Here's the case study. So assume that your father is now 50 years old, plans to retire in 10 years, and expects to live for 25 years after he retires. That is until age 85. He wants his first retirement payments to have the same purchasing power at the time he retires at 40 as today. He wants all the subsequent retirement payments to be equal in his first retirement payments. Do not let the retirement payments grow with inflation. Your father realizes that inflation occurs. The real value of his retirement account or income will decline year by year after he retires. His retirement income will begin the day he retires, 10 years from today, and he'll receive 24 additional annual payments. Inflation is expected to be 5% per year from today. He currently has 100,000 saved and expects to earn a return on 8% per year with annual compounding. Note, neither the time he saves nor the amount he withdraws upon retirement is growing in an annuity. All right, so let's look at the first part. The first part of this is that we know that we'll save for 10 years and then receive payments for 25 years. Perfect. So he wants 40,000 per year in today's dollars for the first payment only. Real income will decline, inflation will be 5%. Therefore, to find the inflation fixed payments, we'll have this timeline. Here today at 40,000, growing at 5%. So what will that be in 10 years? We can put this in our present value or future value calculation. Future value equals present value, 1 plus r to the t power. Or we can enter it into our BA2 plus, which I have here. Enter n, or enter 10 and then n. Interest, air, 5, present value, negative 40,000, payment 0, and then push future value to get a future value of 65,000 approximately. Second thing is he has 100,000 in account, which he earns 8%, which is great. So we got this number, if we put it into our calculator again, to equal $215,892. So in 10 years, the 100,000 actually doubles. Okay. So the fourth part of this assignment is that he wants to withdraw payments of 65,000 because that's what 40,000 is going to be worth in 10 years is really 65,000. And so what we need to do is have this annuity pay out for 25 years. So how much does he need to have? Okay, well, this gets a little tricky. And we definitely want to use our BA2 Plus, and everyone was able to download those for free in there. So here we go. When we enter 25, our interest is 8%. Our payment is $65,155.79, and our future value is 0. To get this payment or to get this annuity for 25 years, we will find out that it equals 751,000. This is the amount he must have on hand in 10 years in order for him to be able to get 65,000 or the 40,000 with the increased inflation. The last part of this is that since our original value of 100,000 grows to 215, we get to subtract that from that 751,000, which gives us that amount that he has to save is 535,000. Remember in class I said he didn't save enough for retirement because he's going to have to save a lot of money. And in order to do that, to get that future value in the 10-year annuity, the payments go in there, and we look at it as n is the time period of 10, interest is 8%, present value of 0, a future value of $535,272.85 is our future value, and we want to push payment to find out how many payments he needs to make, and that gives us $36,949. So for him to be able to do this, he's got to save $36,000, almost $37,000 a month. A year in order to get that payment. Now, if he started way back 20 years ago, that payment would be a lot less. So that's why it's always better to pay now. That is the part of um, the purpose of a saving for the time value of money. If you have any questions, please let me know. I am here to help. And I will be also posting this little spreadsheet or this little document to help you as well in the announcement section. All right. Have a good weekend.